Okay. Hi, everyone. Welcome to the July 24th, 2023 SIG Apps meeting. I'm your host today, Janet Kuo, and I think we have two discussion topics today. The first one is about the PR for changing the stateful set pod management policy. And do we have anyone who wants to talk about this?
Yes, I brought the point.
Okay, please go ahead.
Okay, I prepared just a small slide to bring the point. Let me get it. Can I share my screen? I don't seem to be able to.
Sure, let me make you a host.
Yeah, good. Okay, so it was about pod management policy. I will open the change. So the goal was to see how to make progress on it, and I will share again the use case that we have and why we think it's a good feature, and then we can see how we can move forward with it. So the goal is to change the to be able to change the pod management policy of an existing stateful set. At the moment, it's forbidden in the validation code. So basically, just the feature is about how the pods are started and removed. So basically, by default, ordered ready will start everything in order and wait for the previous pod being ready. And there is parallel, where all pods are started in parallel. And the use case that we have is that we want to change between the two behavior in the life cycle of a stateful set, especially because ordered ready is a default one and parallel is maybe more how to say, we can implement more behaviors with parallel. Basically, the use case where I can change is my main use case for databases, notably, where ordered ready is very good for bootstrapping and scale down and scale up operations, because it's about split brains. It helps to limit and order the leave and join operation, because you might not want to have 10 nodes joining or leaving at the same time. And parallel is very good because you can quickly recover if your pods are deleted. So basically, if your stateful set, your 10 pods are deleted, in parallel, they will all come up at the same time, whereas in ordered ready, you have to wait for all of them to start in order. So the main use case is on most common operations to be in ordered ready. And if you have an issue, you can switch to parallel, or you can switch to parallel and then implement some features with a controller. And I think if we go to the issue, and there is somebody, which is not me, that did a pull request, but basically the only thing preventing you from doing that is I think it's this one, is validation code that don't let you do it. Like there is a it says are waitlisted, I think, the changes that you can make, and it's just not waitlisted. And the question, I think, was whether it is safe to allow this or not. And basically, the issue stopped there on this. But basically, the pull request is ready, and I think it can make progress. So I don't know if anybody can help on that.
So I look at your proposal. I think you mentioned some other alternative that's not working for you. I think one alternative is to, before this is available, you can potentially have the user orphan the pods from the stateful set and create this, and then delete the stateful set and then create another one with a different pod management policy. That should work. And in
Yes.
terms of changing the policy, I think it's usually more likely that you can lose the policy rather than restricting it, because restricting a policy would be breaking a lot of users. But then if you lose it, it's not going to break users. But I think the thing that I think might be worth discussion is whether it's safe for us to introduce this because it looks like users need to know what they're doing before they try to change the policy. And then if we introduce this, maybe it will break some users if they don't really understand it well.
Okay. So it could be improving the documentation, the official documentation, something like this.
Yeah, so I think Ken, another SIG Apps lead, he's not here today, but he knows the stateful set API pretty well. And I will ask him to take a look to see if there's something that he thinks that might be risky about this change.
Okay. Pretty clear. Yes,
So have you? Oh,
yeah, go ahead.
go ahead.
Sorry.
Oh, have you checked why it's why the validation was added in the beginning?
I'm not sure. It's something I can check, but I think it's more like it was restricted by default. I think the code is made to be like you are allow doing some kind of allow list. I will check quickly. I think it has to be implemented one by one. By default, nothing is implemented, and you have to add the ones that you want to be able to modify. And by default, changing something is restricted. Yeah.
I see. Yeah, because for stateful set, most of the fields you're not allowed to change.
So I think it's more like nobody saw the need to do it, so it has never been done. But I think it's this case.
Cool. I think we
But
can.
I think we can speak with Ken asynchronously and see how to fix this.
Yeah, that sounds good. And then,
So
oh, go ahead.
I brought another point in it, which was discuss service level healthiness. So we can switch to it if you want.
Yeah, sure.
All right. So here I'm mostly looking for feedback and to see where the community is heading, to just discuss it. What I want to discuss is two things: service level health check, so application level health check, and protection of PVC. I know it's not SIG Apps, but both are intertwined. And the main use case that we have is we want to do node level maintenances, so node disruption on a cluster where we are running stateful workloads. In practice, basically, my team is operating like 5 different databases, and we use local storage, so data is using local persistent volumes on several thousands of nodes. Currently, and we have another team that is responsible for operating the Kubernetes cluster. And we have implemented an interface between our two teams to be able to do maintenances. And right now it's relying on PDB. And we have a few limits with it. One is the ability to expose a service or workload level health checking, because the PDB relies only on readiness probes. Whereas there are some states of a cluster that is global in a way and cannot be easily reflected on pods. And I will go deeper on each point, and don't hesitate to cut me if you have any questions or remarks. And the second part is that typically stateful workloads, they are both compute and storage. And we have some cases where we want to avoid doing a maintenance on a node if we know that the application is not healthy. And in some points, so most of the time it works because there is a pod and the PV together, scheduled together. But in some cases, the pod is not here and the service is degraded and there is just the data, and you don't want to enter maintenance when you have this. If we want to go deeper on service level health check, as I was saying, basically, when you are operating, especially with cluster with databases, you have a state that can be per node per pod, and a state that is global to the database. For example, what can be global is the data redundancy that is degraded, like you miss some data somewhere, but each pod is running perfectly well. You can have like issue with the cache or even degraded performance, like its service level. And you want to find a way to expose this information to the pod distribution budget to prevent eviction and to prevent the maintenance from happening. So a voluntary distribution to happen on your service, on your stateful set. I think on our side, we have studied like 3 approaches to do that. And the first one is that what we are using right now, and we are not happy with it, is that we have a controller that changes the max unavailable field periodically. Basically, if it sees that the database is not healthy, it will change the max unavailable to switch it to 0, and which basically will prevent any eviction from happening on the pods that are protected by the PDB. But it's not great. First, because it's in a way eventually consistent. It means that the database might change. The time it takes for the controller to see that the database is NLC is rather slow, like it takes 10-30 seconds, and the PDB can be much faster than that. So for the time elapsed between the time where the database is NLC and we see it, we could have evicted multiple pods in this case. And also, if the controller is not running, you are left without any protection at all. And there's no way to block the system if the controller is not there. An alternative is to use service health check pod. Basically, you create a canary pod, you bound its readiness probe to the health of the service itself. So if the service itself is down, the readiness probe of this pod will be unready, and it will block the PDB if you have only one disruption allowed. And you can have the same issue as the other one, as the moment where the database is NLC and the moment where the pod will switch to NLC. That can be like up to a minute, where it can be where the service in a way is left unprotected. Also, because there is, you can only protect with the PDB. Pod can only be seen by one PDB. It can be only protected by one PDB. And some cases, some implementation where you have multi-PDB, like for example, one for each availability zone, you can have some kind of conflict happening, or you need multiple canaries, so it's not ideal. And the last thing is to add a validation webhook on the pod's eviction subresource. Basically, every time something will try to evict, there will be a synchronous call to the to some controller somewhere that will check the health and accept the eviction or not. So I think for us, doing synchronous, doing it this way is the best way, because first, we don't have this issue where the state is has changed, where it takes time for the state to update. Here you do the check when you accept the eviction. And what was the other point? And if the controller is not running, the webhook will fly, so you won't process an eviction. And I think we are going toward not exactly validation webhook. I will speak about it later, but I don't know if there is a movement in the community to answer this problem of service level health check. I don't know if you have any information about that, or people we could discuss about this issue.
So I have a question about the third option. So when the webhook is not running or it's not healthy, it's going to reject the eviction.
Yep.
And
in this case, we want to be fail-safe because we don't want eviction to happen if we are not aware of the state of the service.
I see.
But in practice, it's not how we are going to implement it. We are going to do it a bit differently, but it's the direction where we do synchronous call to do that.
Got it.
Yeah, we have a similar use case here at Apple. And one of the things that came up is, like, can we actually outsource the definition of what healthiness means to an operator which is managing the workload instead of having the pod level gates be the only, or health checks be the only way to determine if the entire workload is ready or not? Can we have the workload operator decide and then tell if the entire set of services are like working correctly or not? Does that make sense? Whatever
I see. Basically, you mean that the controller is sole responsible for doing this kind of operations, like to delete a pod?
Yeah, because like that operator should have knowledge of what the workload is supposed to run, if it is down or not, if it has got some performance degradation happening.
It's a good point. I think in our case, the thing is that we have two levels. Like one is operators, and typically we are on two controllers. Like it's hard to have one thing that have all the knowledge. Like the operator might know about the health, but we might want to add other things to it, other parameters to check before doing anything. Like for example, I'm thinking about performance monitoring. Like if you breach the SLOs that you provide, and the operator cannot really help you with that. In this case, it cannot really do the operation. And I think there is also the part where, in terms of maintenance, like it depends, I guess, on the implementation of how you handle the maintenance, but typically it's a bit reactive, where it's the maintenance systems that will ask you to enter this node in maintenance through a drain, for example. And then I guess the controller, the operator will have to have something to manage this part. I think it's done on Rook, where, no, it's not done on Rook, it's different. But yeah, I think it you depend on the operator, and yeah, in theory, it could be the operator that manages almost everything. But you will be limited.
Yeah, I think if you have Suricata or other monitoring tools that you want to use, perhaps having an operator which understands the SLOs of the individual workload, and based on that, if it can update what healthiness means, I think it should be good. But even if you have multiple controllers to do the same thing, you can have different conditions, right? So one could be performance related, and the other could be what the actual liveness, healthiness, readiness, and all those things could mean. But I'm wondering, again, this is up to like the SIG to decide. What should be the best course of action is something that we need to come up with, is something that I'm going to agree with.
Yeah, if I
Do
can
you-
add.
Yeah.
Go ahead, Philip.
Yeah, that Kubernetes is also like struggling with problems like these when you have a node maintenance, and they are using also your approach with validation webhook and catching the eviction resource requests. Although this has like additional problems when the webhook fails, then you are basically corrupting the eviction process. And I know there are some discussions regarding this in the in-use cap. I sent link to the chat, but I don't know many details about the cap. Just want to highlight it.
Oh, if there is some discussion happening, I'm not aware of it. So
yeah, this is like I think this is. Sorry, go ahead.
No, I was just saying. I will try to find the title of the change.
I think the cap
should
has
we actually focus on that cap and then like try to comment there and reach some consensus?
Yeah, okay. I missed the cap, so probably I will read it and see if we can get something out of it. Yeah.
No. Like I think it's better if we start with a GitHub issue. Do we have a GitHub issue around this? Philip, I think that's a question to you. Like, did someone create an issue and then based on that they have created this cap?
I don't remember, but I can look around and think with you if I find it.
I think the best course of action would be to at least get started with the GitHub issue if it is not there, and then have a follow-up meeting, like once we discuss asynchronously on that GitHub issue. Does that make sense?
Yeah, that was for me. Especially just interested in starting the conversation somewhere. So if we have a place, then I'm good with it.
Yeah, I know for sure that Kubernetes had like many discussions regarding this, so I can look around and we can sync in the Slack Kubernetes and see.
That works. Jenna, do you want to add something there?
No, I think so. I look at the issue, it looks like it's pretty old. It's from 2021.
Maybe a bit stale, but check the last update. Oh, it's still active, so yeah. So let's we can do it asynchronously. I don't mind it.
Okay.
Okay, and I had another point, which was the part about PVC, but I guess it's not exactly SIG apps, but just also to add for conversation. Basically, we have cases where we are running a stateful application, and we have data as it is local on the node. And PDB cannot really protect all the cases because it only protects, in a way, data when when the pod is running. When the pod is not running, you might have a persistent volume that is bound to something, and it won't protect the case. And why it can be why it can be bad, especially in the context of maintenance, is that when you have there are some cases where pods can be forcefully ejected from a node, and then, for example, there is node pressure, like ephemeral disk node pressure. And if not all the pods are running, maintenance can be performed on the node, whereas we know that the PVC should be kept, like the PV and the PVC should be kept because there is a degraded state above. So basically, the eviction mechanism, you cannot evict in a way data, which doesn't really make sense. But there are cases where we want to prevent a drain from being successful if we know that removing this data would be dangerous. And another use case is when you are doing a running update. If a node is being drained right in the middle of your update, you will get your pod that will be pending. While it's not really an issue to replace, because part of the life cycle is to be able to replace to handle this kind of failures. But you might want to avoid this voluntary disruption as much as you want. Here it's a very precise use case, but it's really protecting against pod. And the solutions that we're working on to solve both of these issues is to have some kind of node level disruption API, where we can create a disruption of a node, and it will check for budget, which works a bit like PDB, except you can select a pod. You can select pods, you can select PVCs, and you can also perform a service level health check. So that's the direction where we're heading. I don't know if you have feedback, if you have seen people with the same kind of issues as us. Yeah, just open to feedback here.
Just trying to understand, you have two different approaches. One is node level disruption, the other is application level budget. Is that what you're saying, or you want to use a combination of both?
Here, basically, when you so it's still work in progress, so it's experimental on our side. Basically, you create a new node disruption on the nodes, so you are scoping nodes, and there is each application, each workload, they can have their budget. And there is a controller that will make the connection between pods running on nodes and PVCs being bound to nodes through their PV, persistent volume. And this way you can know which budget are impacted when you do a maintenance on a specific node. And then you can check for each budget if all of them allow for disruption.
Got it.
Basically, the issue with eviction, in a way, is that it's always pod level, and we needed something, a way to how to say, like to speak about the node disruption and not a pod level disruption.
Makes sense, and we have similar problems as well. And the way we are trying to work around is we have extended, and again, this is not open source, some API like we have extended PDB to actually make a call to an external system which understands what's the state of the node. That is how we have been working around. But I think having a generic mechanism for having generic extension mechanism for PDB would be great, where we can make either external calls or talk to another service, which may be within the bounds of Kubernetes or outside the bounds of Kubernetes. That is how we are looking at. Like, say, for example, can you have something in the pod spec which says you have run the health checks and say if they are failing, so the pod is not in ready state. Can you also check with an external service which understands what the state of the node is, right? So that is how we are trying to work around problems. But again, having something in the spec which can make either a HTTP call or something to another service which understands what is the state of the node and then says yes, it is healthy, or yes, it is not healthy, might be a good way to look at. And I think we had this discussion in the past where some of the leads were okay with having an extension mechanism, but they wanted us to discuss with SIG Apps if it is possible to do, like adding something to the spec which makes, like, sort of have an extension mechanism to PDB. For that, do we need to, I think it was mentioned that we need to talk to SIG Apps and get their approval on moving forward. But I believe there has been not much of resistance from this SIG.
Okay. In your use case, was it for the use case of maintenance on nodes, or was it more generic than that?
It is more generic than that.
Okay. And do you have links like for the discussions that you had, or things that like designs that you, like you said, it's closed source, but maybe you have an explication somewhere on the mechanism in details? I don't know.
No, it was just happening in the SIG Apps call like this.
Okay.
But I can get started on creating an issue, and then we can converge there and see if we have some agreement, and then come back to SIG Apps and SIG Arch and see if their views have changed.
Okay.
So I'm thinking about the node level disruption. Are you, because usually when you deploy an application, you don't touch the cluster level things, and node level disruption seems to impact every application on the cluster.
Yeah, in this case, like node level disruption, it will be for the, in a way, the things that touch the node. So basically, if you are doing maintenance, like a simple user, like a normal user, they won't create node level disruptions. They will be created by the operators of the team responsible for the Kubernetes cluster, or maybe like through systems like autoscalers or maintenance system. They will be the one creating the disruption, but not the users. So the users only provide a budget to show them to advertise constraints and constraints. Yeah, and not everybody needs this amount of constraining. It's really for stateful applications that are really critical. So basically, application level budget is users, and here it's really Kubernetes operators that then they can touch global cluster objects, whereas this one is namespaced.
And then this disruption budget, you are thinking about something like max number of nodes that can be unavailable.
Nodes are number of disruptions, because in our use case, we know we can also have a disruption that touch multiple nodes, but it's in a way detail, but yeah.
Yeah,
so I have a more complex design docs for that I can share if anybody is interested, but that's where we are heading.
I think Kube always has been like application-centric infra. If you want to bring in Node API, it may be hard to convince, but if you can represent those node conditions via some health checks at the PDV level, I think it might make sense. It's just that we are working around the problem, no doubt about it. But to me, like Kube always has been like application-centric infra. So that's why like treating the nodes as like pets is something that people may not like. Does that make sense? Like whatever.
Yeah, I understand.
Yeah, I agree with that.
Yeah, so if we can represent those node conditions as a way of saying that there is some external entity which is saying that the eviction should be stopped at the pod disruption budget level, I think it would be much more.
Yeah, but there is still the hole where you have there is a hole where you have persistent volume as well, and there is still the use case where when you are draining, you might want to stop draining from happening if the data there is important, if it cannot be lost for a moment, or it shouldn't be lost if possible.
Yeah, to be clear, that actually falls in the app realm, right? So like if the required data is not present, there has to be a way for PDB to know that I cannot drain, or the PDB controller to know that I cannot proceed with evicting the pod because the required data which is needed by the app is not present. Yes, that actually ties back to what we were discussing earlier. But it has to be something more natural in terms of how the pod and the workloads and the data needed for that workload is actually represented.
Yeah, I agree. Having on the node level is really like more convenience, because for PV, you really have to know the node. So the API should be aware of the node, whereas an eviction, it's really on the pod. So there is a need for something like, I don't think it's a perfect API, but it's, for us, it's the only way, the clean way we found to really expose this eviction of potentially data. It's not really clear, but yeah, it's the only way we found to expose that. But if we find a way to do it cleanly on the PDB, I mean, why not?
I think what you mentioned is right. So there is no way to express that intention at the API level. That for sure is there. So we need to address it. How we want to address it is something that we need to discuss and then converge.
Also, I think like even if you do not want to drain the node, you will want to drain the node eventually. I think also in KubeVirt case, they probably are missing a feature like a eviction intent, that you want to know that you should leave the node and you want to migrate the data or migrate the workloads like eventually. So that's like, that would be good to be captured in the API as well.
Yeah, I think we need to have something in the API, and how we need to use that API in the code is something that we need to think through. Like, should we have some way to make a HTTP or gRPC call, just like, so if you look at scheduler, like we have list of core scheduler plugins that are in the scheduler binary, and you can also make some extension HTTP calls or HTTPS calls to other constraints that we want to have, which are customized, and they will be honored by the scheduler. Say if it fails, scheduler says, no, I cannot fit the pod on that node because XYZ constraint has failed, which again is a custom constraint. So if we have some extension mechanism which says, apart from checking the pod readiness, there is a way in the spec to make a call to some other service which says, which perhaps is going to do node level checks, the data level checks that are needed, and then come back and say, yes, you can go ahead and evict, or you can consider the pod to be not healthy enough to make the eviction. I think that might be okay. But again, this is up for discussion. Does that make sense? Whatever I mentioned?
Yep.
Okay.
Thanks.
So I can go ahead and create an issue for this, and we can discuss on GitHub and then perhaps come back for the next meeting and see where it goes.
That sounds good. Thanks.
Thank you.
Okay. So I don't have any other points on these topics.
Cool. Does anyone have anything they want to bring up for discussion? If not, we can end the meeting early today. All right. Thanks, everyone.
Thank you.
Thank you.
Thanks.
Bye.
Bye.
You.